Hey everyone, welcome to this video for P8105, a course on data science. This is the first in a collection of 3 videos on iteration, the process of doing the same thing over and over and over again. In particular, this video is going to focus on writing functions. I'm going to start by giving an introduction using slides. After that, I'll demonstrate the material in a screencast. Skip around to the parts of the video you find most useful. To get the most out of this, please code along with me. Everything is available at p8105.com, and there are links in the description below. Awesome. Let's get started. Great. Let's get started talking about writing functions. First thing to know is when to write a function. And sort of common knowledge, everybody says basically the same thing. If you use the same code in a document or across multiple documents, if you find yourself using the same code more than twice, it's time to write a function. You might write code once and then copy it once and maybe change a little input and think like this is okay. By the time you get to that third time of using the same code again, it's time to write a function. So why is that true? Why is that the case? And this is sort of speaking from long experience of when I haven't used functions and recognizing what happens. So let's say I write some code and it's maybe 5 or 6 lines long, and then I need to use something that's basically the same somewhere else. Not exactly the same. I need to change something on like line 4 of that 6-line piece of code, and now I want to get some slightly different output based on something that I've changed. And then later on in that document, I need to change that thing again. And I change whatever's going on line 4 of these 6 lines, and I get like third output from what is basically the same piece of code. It's almost the same, I've just changed one little thing. Now, later on, I might realize that in that 3 lines of code, I actually need to add something to line 2. I need to edit line 6 to do something slightly different. Now I got to remember to take all of those changes and put them in the same code chunk that I had the second time, put them in the code chunk I had the third time. And when I start doing that, things are going to go wrong. I am either going to forget, I got copied line 2 from here to here, but I forgot to copy it the third time, or I copied the whole thing and then I overwrote whatever had been different from this code chunk on line 4 versus the first one. Whatever, I'm going to start making mistakes. Now, even more than that, this whole process is harder than it needs to be. If I had some piece of code that says, here is the process that you're going to use, then rather than having to change it 3 times, I change it once and I reuse that code now 3 different times. I only have to change things 1 time though. Other things that can go wrong, it's really difficult to read code that has been copy and pasted a whole bunch of times. And the reason is you look at a code chunk and the next one looks exactly the same, and it's really tough to identify like, all right, here on line 4, that's where something is different from this version to this version. It's just hard to use. So all of these reasons, and there are other ones, right? But these reasons in particular, having code that is easier to read, having code that is easier to change and fix, and preventing mistakes from trying to reuse the same code a whole bunch of times, this is why you should be writing functions. And the truth is, the first time you start, when you just get started in all of this and you're like writing functions at the beginning, you are going to think, this takes more time. It's harder to write functions than it is to just copy and paste. And in the super, super short term, that's probably true. In the medium term, it's absolutely not true. And in the long term, it's absolutely not true. You're going to get better at writing functions, but you have to practice. And also, when you are writing functions, or sorry, if you're copy and pasting code now, it might feel like you're saving time. But later on, when you have to reuse that code or reread that code or do something different with that code, that's going to take more time than if you just had like a nice organized function over here that you can read and update. So I get initially why you might think, I don't want to start doing this, but it's really good for you to practice and to get in the habit of using functions anytime you find yourself reusing code. So, all right, that's like my sales pitch, why you should be writing functions, and I think it's similar sales pitch that anybody else would tell you. So, all right, let's get into it though. What is a function? So if you remember back in the day when you were taking math classes, you talked about mathematical functions in the sense that you have an input to a function and then it does something to that input and it spits out a result. And the idea is that you want, in that mathematical process, you want to abstract that sort of process of putting in an input and doing something and getting something out. So you might think, for example, that 4 equals 2 squared is a calculation. You have done something very particular to an input, operated on it, and gotten an output. But the function, some output y depends on some input x, and then that process of squaring it is the sort of thing that happens in the middle. You get an input x, you get a process, and you get an output. That's a function, and that's sort of really what we're interested in. So we might, for example, in code do something like taking a sum of a vector of length 3 is to like sum the first plus the second plus the third. That's a specific computation, but taking the sum or taking the mean or taking something else of some arbitrary input, that's a function, and those are the kinds of things that we're going to be trying to do. So if you have some process that depends on some small number of inputs and then does a thing and then spits out the result, that's an exact use case for when you need to write functions. And if you need to do this again and again, changing the inputs just a little bit, time to write some functions. So just to sort of drive home what functions look like in the end and how you should be thinking about them, you're going to have inputs, then you're going to have some code that does some stuff, and then you're going to have outputs or return objects. And so you're going to think about these as arguments to the function, and then the body of the function and the return objects. And at the outset, often these are relatively simple, but they can get quite complicated. Right? We've seen in some cases, we've been using functions along the way. Things like taking the mean are relatively simple. Things like creating data frames are actually a little bit more complicated. Things like ggplot are functions. You can have complex inputs, you can have simple inputs, right? And you can have complex parts of the function, or you can have simple parts of the function. But every function, I think, consists of these three basic pieces. All right, so a little bit more specifically, the arguments are the things that go into the function, and these are inputs that are going to be used inside the code body, inside the body of the function, inside that code. Often, depending on the function, often these take default values, and that users can overwrite those if they need to. Sometimes you're going to just know you want na.rm to be equal to false. Sometimes you know you're going to want to have a pre-specified sample size in your function unless somebody does something different. Sometimes you want to have a default value, sometimes you don't. And when you're writing functions, that's going to be something that's up to you. When you are deciding in your own functions what names to use for your arguments, it's going to be up to you to decide what you want to call the first argument, what you want to call the second argument, and so on. Try to be reasonable in the sense that, of course, you're going to be using this function, and you want to know as you're sort of looking through your code, all right, what are the things inside of my code, or sorry, inside of my function, what is that code trying to do? And can I tell from the argument names roughly what's going on? So I generally use things like X or Y or even Z if I'm going to be putting in a vector. Things like mean X, that's going to be something that is reasonable, right? If you're going to be putting into your function a data frame, you might use df for data frame or data. You might use n for the number of rows or the sample size or something like this. You want to use argument names that are pretty transparent, and I think that helps. So then the body of your function is just the code that does some stuff. Often that structure looks a little bit like the following. You start out and you say, like, let me check that these inputs actually make sense. Let me do something that's reasonable, and if it's not reasonable, I'm going to stop right here and spit out a message that says, the inputs you gave me don't actually make sense. Thank you very much. Please try again, right? After you get past that little bit, often you perform some operations. You're going to say something like, I need to compute some quantity, or I need to do some subsetting. I need to fit a model. I need to spit something out after that. And then sometimes after you've done whatever operations, you want to structure that return object, the thing that your function is going to spit out. You want to structure that in a way that it's easy for you to use after the fact. You want to sort of put things together in an organized way. Okay. All right. So then you have to return an object. Sometimes this is implicit. It's implied by whatever the last thing that you did was, or you can be very explicit using return this particular thing. I encourage you to be explicit about it. I think that's often a little bit clearer than just being implicit, but again, that's a little bit up to you. Sometimes your function is going to spit out a simple thing. Sometimes it's just going to spit out the mean, and that's it. Sometimes it's going to spit out a collection of things. Sometimes you're going to want an estimated mean and a standard error for your mean and a test statistic and a p-value that goes along with that. Sometimes you want all of those things. The way that you then structure this is going to be a little bit up to you. If you're spitting out one number and you just know that that's going to be an estimate or a p-value, well then great. If you know you're going to be spitting out 4 numbers, maybe you want to organize that into a vector or even a data frame or a list or something like this. You want this all to sort of be something that you can understand. Okay, one of the things that can get confusing when you get started writing functions is the concept of scoping. And this isn't something that we need to understand in a lot of detail, but it is something that is important to at least have a sense of at the beginning. So most of the time when you're working on R and you're analyzing data and you're manipulating things and making plots and whatever, all of the variables that you create are over here inside of the global environment. And those are things that are available everywhere in R, so to speak, right? So then you go and you execute a function, and maybe this is a function you've written, or maybe it's a function somewhere else. When you execute a function, R sort of goes off to the side and says, all right, great, here is the environment for this function, and it's going to know about things that you pass into that function. And great, it's gonna work over here, and you're gonna go through the body of the function, and you're gonna get to a return object, and it's gonna spit it out and go back to the global environment. If you've written a function though, and you have some line of code that doesn't depend on the arguments, but it depends on something else, you've got some variable that you're using over here, R will try to say like, all right, that doesn't exist inside of this environment, but let me go look over here, back in the global environment. Maybe I can find what I'm looking for over here. And that, generally speaking, is something that you want to avoid when you are writing your own functions. What it means is you've got code over here that actually doesn't just depend on the inputs, it depends on something else that's happened elsewhere in your code. And that can be problematic if you change the way that you're processing things, if you restart R and you get rid of some variable that you've created, if you've done something that changes your global environment, but your function somehow depended on that in ways that you didn't mean for it to, well then now this function might not behave in the way that you expect, right? So this is, like I say, this is one of those things that is confusing at first. You want to make sure that the code inside of your function is sort of entirely self-contained and dependent only on the inputs that you're putting in. You want to make sure that you're using those inputs in the right way. It can get a little bit confusing, but that's sort of the basic idea, is make sure that everything is sort of self-contained over here, and recognize that if it's not, R is going to try to go back to your global environment and find something to make your code work, and that's usually a bad idea. All right, so I also want to mention very briefly, I had sort of said in writing functions, you often start out with a little bit of stuff that does checks on the input type. And often what you do here is something like conditional execution. There are other places that you might use this inside of a function, but I think primarily it's useful based on checks on like what the input is. So in short, what you're looking for is saying, all right, if you hand in something that looks like this, I want my function to do this. And if you hand in something that looks like this, I want you to do this. And so that if you give me something like this is a logical condition, you're going to say, is this numeric true or false? Or is this character true or false? And if it's numeric, I'm going to do something. And if it's, what did I say? Numeric, if it's character, I'm going to do some other thing. And then for everything else, I'm just going to do something else, right? So this conditional execution turns out to be helpful. Often I use it to say, if I want my function to do something with numeric variables and somebody gives me a character, well, if this is character, just stop doing what you're doing and forget about the rest of the function. Just quit now while you're ahead and spit out some message. So that's sort of where I think we're going to be using conditional execution. All right, so we got why to write functions, when you're going to write functions. We know sort of what functions are. Now we're going to talk about how. And the way that I think the way that almost everybody starts writing functions, at least at the outset, is to start very, very small with something that is a working example. And the idea here that I have is if you use code once, you don't need to write a function. If you use code twice, you're starting to think maybe you need to write a function. But now you've got working examples. You know this sort of code works, this code works, and I know what I need to change to get from the first example to the second example. That's sort of what we're looking at. So I would start from there and then say, let me try to take this 6 lines of code that I already know work, and I'm going to try to turn that into a function that has that one input that I care about. And I'm going to start as small really as I can, right? And that's sort of where you're going to go. I generally recommend that you try to have relatively short functions that do one thing and do it relatively well, and that interact with each other in ways that you might need them to, right? Don't try to write one function that's going to take in an input and clean the data and do the analysis and do some other stuff and make a plot and do whatever, right? Have separate functions for different parts of whatever that analysis pipeline might be, if that's something that you need to do. Try not to make things too complex. It's going to be easier to understand. It's going to be better that way. And then the last point is one that I think often trips people up is you might be able to come up with a function that is just the super cleverest idea you've ever had, and it works really, really neat. But it's often better, instead of trying to be too clever with the things that you're doing, just make sure that your functions are clear. Because again, when you come back to this 6 months from now, you might find you outsmarted yourself, right? You've written something really clever that you have no idea how it works anymore. Clarity is going to be better than doing something that's just like super, super neat, right? The other thing that I like to bring up at this stage when you start talking about writing functions, again, is to start small. And so this is, if you're writing like lots of stuff and everything's really complicated, the idea is, instead of starting out, if you need to build something complicated like a car, don't start with one wheel and then two wheels and then the body of the car, because at step 1 the thing doesn't work, at step 2 the thing doesn't work, at step 3 the thing doesn't work, and then all of a sudden maybe at step 4 things are working. Instead, if you got to build a car, make a skateboard, and then something a little, make a scooter, and then a little more complicated, make a bicycle, and then like add an engine to it and you got a motorcycle, and then like start moving on towards a car, right? Like at each step of the way, you're adding just enough more complexity. You still have a grasp on what's going on. You're moving in the direction of your goal, but every step of the way, you've got something that works, something that you can check, something that you can understand, and that is an important way to go about writing functions and really doing anything that's kind of complicated. Okay, so with that, we're going to start writing some functions. We're going to write some functions. Now, the first place that I'm going to get started is doing something really simple. So do something simple. And when I say I'm going to do something simple, what I mean is, very often what you end up doing in statistics, for a variety of reasons, is if you've got a collection of numbers, you subtract the mean and you divide by the standard deviation, and that's where we're going to start. This is going to take a sample and convert whatever that sample is into a collection of z-scores. Z-scores being the result of taking these things, subtracting the mean, dividing by the standard deviation. So that's where I'm going to get started. And I'm gonna do this again, not by jumping straight into writing a function. I'm gonna try to write some code that does the thing that I want, and then I'm gonna worry about adding in the stuff that gives me the function that I'm interested in. So let me just start from a working example. I'm going to create an x vector that comes from a normal distribution, and I'm going to get 30 numbers here, and I'm going to set the mean equal to 5, and let's do the standard deviation equal to 3. Okay, so I've got an x vector here. Oh, I guess like before I get too much further, I'm going to go ahead and run this bit of code. I don't know that I'm going to make any plots. I don't know that I'm going to do a bunch of other stuff, but I like to make sure that that's all set just in case I make some kind of a plot. All right, great. So I've got my x vector here, and if I wanted to do this thing where I subtract the mean and divide by the standard deviation, what I'm going to do first is, I guess I'll print my x vector to convince myself that, yeah, that looks like some numbers. Probably the mean is about 5, probably the standard deviation is about 3. We'll check on that in just a second. I'm going to take the x vector, and I'm going to subtract the mean of whatever that x vector is. Let me just sort of, again here, double check that this works. That didn't yet. Okay, so the mean is, yeah, it's high. It's a little bit above 5, but it's sort of in the right neighborhood. And now let me divide by the standard deviation of my x vector. Okay, and I'll double check that this is somewhere around 3. Close enough. All right, so what I'm going to do now is, again, this computation. I've generated x, and now I've computed the mean, subtracted the mean from the x vector here. Let's check. That works, and now I'm dividing all that by the standard deviation, and now I've got these things that are called z-scores, and this is helpful because now on this scale I can say, you know, is this 1 standard deviation above the mean? Is it 2 standard deviation above the mean? This gives me some way of like scanning things and saying like, all right, whichever number had a z-score of 2.36, here that looks like about 7, that's kind of big. This is clearly an outlier in the other direction, or maybe an outlier. It's large, it is a couple of standard deviations away from the mean in the other direction. And that's a useful summary to just sort of keep in your back pocket. Again, mostly what I'm going to be interested in right now is writing functions. I'm not going to talk about how great z-scores are. Z-scores are pretty great though, so just know that that's a useful thing to have around. Okay, so this is a pretty simple thing though. All I'm doing is thinking, if I wanted to compute z-scores, I need to take whatever my input vector is, I need to compute the mean of that vector, I need to compute the standard deviation, and I need to do this operation. So this is really going to now be the kind of thing that I want to do in the body of a function that takes an input vector and computes z-scores, right? That's what we're doing now. So I want a function to compute z-scores. And you might think to yourself, I can just write this line of code. Sure, you can, but also you can write a function. So let's try that. Now I'm going to try to give my function a useful name here, and I'm going to introduce some of the notation that goes along with this. So my function name is going to be z-scores, and this is a function, right? I am setting z-scores equal to a whole function, and it's going to do all kinds of stuff. That function is going to have some arguments, and here I'm going to say that argument is whatever numeric vector I want to pass in. I'm going to call this a function x, and now I need to write the body of my function. And the body of my function is going to exist between these two square brackets. Everything that happens between these brackets happens inside the body of my function. And what I'm going to do here is say, this is really what I want to do. And this is like where things start to get a little bit confusing, is inside the body of my function, I don't want to use the variable name for the object that I created here. I want that operation, the body of my function, to depend on this input. And this is an input that I have named x. That's what it's called. So inside my function, I want to use only something that's named x, right? And this is where, again, if you're worried about like, how does the function know what inputs to use and what variables and all of this, keep in mind you are naming the input x, so use x everywhere you want to sort of like operate on that input. Okay, so hopefully that starts to make a little bit of sense here. So I'm going to do something like we did above. I'm going to take x minus whatever the mean of x is, divided by the standard deviation of x, okay? And I'm going to call this z, and I'm going to be very explicit here. I'm going to return z, okay? Okay, fantastic. So let's take this and run it, and so far nothing has happened. So far, like nothing has happened. I've written a function, and my function is now sort of sitting off to the side doing whatever it needs to do. It's waiting for me to operate with that function. So let's try this. I'm going to take z-scores, and I have created an x vector previously, so I'm going to operate z-scores on my x vector. Now again, I want to just be, this is, again, if you're new to writing functions, I want to be very clear about how this works. So I am telling z-scores that the input here is the x vector. I'm saying wherever you see an x inside the body of this function, that's where you're going to plug this thing in. So I'm going to take x vector, and it's going to show up here, and then it's going to say this minus the mean of it divided by the standard deviation. That's sort of the process that's going on here. So if I run z-scores on my x vector, I get exactly the same thing as I did if I ran it right here. So great. I've got a function here, and I can run that function on an input vector, and we've got z-scores. This is pretty fantastic. Now I'm going to try a couple of other things here. Try my function on some other things. So I've got my x vector. The first thing that I'm going to do, let's just try what happens if I do z-scores on the number 3. Okay. It gave me an NA. And you might think to yourself, why is it giving me an NA? Well, you can compute the mean of 3, but if you try to compute the standard deviation of 3, you're going to have some problems. You need more numbers than one number to compute a standard deviation. So you can't do this. Okay. What happens if I try to do like z-scores on my favorite character vector? My name is Jeff. Let's see what happens here. Now I've gotten an error, something mean minus mean x. You can't take the mean of a character. It's just giving me an error there, and that's breaking too. Okay, so let's try some other things. What if I did z-scores on, let's just take a random data set. I think MT cars is a data set floating around. This is a data set about cars and miles per gallon and stuff. It's built into R. The point isn't that this is a data set. The point here is like, what if you wanted to try to compute z-scores on something like this? And then you just plug in the MT cars data set. Now it's going to say something weirder. You can't coerce to type double. Basically, you can't take the mean of a data set any more than you can take the mean of a character vector, right? You can take the mean of a list of numbers. Okay, right? So that breaks. Let's try one other thing. Z-scores on the following. I'm going to do C, true, true, false, true. And that, as it turns out, has worked. And you might think, how come you, what? If you remember back, when you start plugging in R, you take something that's logical and you start trying to do things that you would do to a number, it's going to read this in as a sequence. It's going to coerce this. It's going to force this to be a sequence of zeros and ones. And it turns out, if you start trying to take the mean of this and the standard deviation of this, it'll convert this to 1, 1, 0, 1, and then compute the mean and compute the standard deviation. Now, my point with all of this is each of these is an instance in which I really would prefer my function to just break. It does something wrong in every instance, but it sort of, sometimes it gives an error message, sometimes it gives an NA, sometimes it gives an actual response, and it's just not something that I think makes sense. I don't want to compute z-scores for true, true, false, true. So what I'm going to do now is update my function. So let's try one other thing. Updating my function, the goal here is to make sure that if somebody puts in something that doesn't make sense, if I try to compute these z-scores on a data frame, I want this to not work. So this is where I'm, for now, going to be using conditional execution. So what I want to do is write a few data checks. I'm going to say if, let's say, not is dot numeric x. So again, if I take x and I plug it in here and it's numeric, this is true. And then if I say, is it not numeric, if somebody passes in a data frame, this is going to be false. If somebody passes in something that's logical, this is going to be false. What I want to do is stop doing what I'm doing and say input must be numeric. Okay, so I'm going to update this. Again, I'm checking every step of the way to make sure things work. I can still compute z-scores. These are the same z-scores as before. Here, I'm still getting an NA here because the input 3 is a number. But here I get an error in z-scores, input must be numeric. Here I get input must be numeric, and here I get input must be numeric. So I'm doing okay. I've stopped things and I've given an informative message about what happens. So the next thing that I'm going to do, I'm just going to put another if statement. So if it is numeric, great. If, let's see, I think what I want here is the length of that input x vector. If it's 1, I want things to break. If it's 2 or more, maybe that's fine. I don't feel great about standard deviations unless you have 3 numbers. So if the length of x is less than 3, let's stop again. Input must have at least 3 numbers. Okay, so now I've got a new z-scores function. I'm updating that function and applying it to the x vector that I created previously. That still works. Feeling great about that. Let me check here. Input must have at least 3 numbers, and then must be numeric and so on. So everything so far is working the way that I need it to, and I'm feeling pretty good about this. So let me knit real quick. Oh, now I'm getting these error messages. Error, false, true. Okay, these should give errors, just so that I'm clear with myself about what happens. Yep, so I've got a bunch of errors here. Okay. Let me commit both of those. A first simple function. Great. So I've got here an input x. What I'm going to do next is multiple outputs. Right? So I'm gonna start adding some complexity to my function. I'm going to try to make it a little bit more interesting, and then we'll do some other stuff after that. All right. So I'm going to get multiple outputs here, and sort of as a result of that, I think the body of my function is going to get a little bit more interesting. So what I'm going to do now is, instead of saying like, all right, you pass me a vector and I'm going to compute z-scores based on that vector, I'm going to do something a little bit different, where if I pass in this numeric vector, it's going to compute the mean and the standard deviation, and it's going to spit two numbers out. I'm going to get both of those at the same time. That's sort of what I'm looking for here. So I'm going to start by writing a function, and I'm actually going to start by copy and pasting this whole function and just updating it. So let's say I want mean and standard deviation is going to be a function on x. I'm going to keep the same data checks. It has to be a number. I don't want the mean and standard deviation of a character. It has to be at least 3, because you got to have 3 numbers for a standard deviation, I suppose. And what's going to change here is the return object, meaning instead of computing the mean and standard deviation and applying those to compute a z-score, I want to get the mean, and then I want to get the standard deviation, and I want to return both. So I'm going to do that first. Let's say mean of x is equal to mean of x, and standard deviation of x. Variable name is equal to the standard deviation of x. And now I've got 2 things that I need to return. And so I need to start organizing these outputs somehow. You've got a couple of different ways that you can do this, at least. Some folks like to use like a list, where you would say, what are we going to call this? Like the mean is equal to mean of x, and the standard deviation is equal to standard deviation of x. We haven't spent a lot of time talking about lists, so I'm telling you now, I'm sort of saying, if you've got a variety of things you want to put together, you can make that a list. I'm not even going to run this. I'm just going to, in the back of your mind, I want you to hear the word list a couple of times for later videos in this session or this sequence. So what we're going to do here is make this a data frame, and hopefully this is going to work for us. So now I've got mean and standard deviation, and now let me check here, check that the function works. I want mean and standard deviation of my x vector that I have floating around. So cool, actually I'm kind of excited about this. So I passed in an input vector x, and I've got 5.98 is the mean and 3.30 is the standard deviation. And I think I'm actually feeling pretty good about that. Again, the goal here is you've got some inputs, you've got your input vector, and you're computing a mean and a standard deviation. And I guess, let me just sort of double check. I've been using the same x vector a bunch of times. Let's update this. Let's do rnorm. And I'm just going to make this 100, 1,000. And I'm going to leave the mean at 0 and the standard deviation at 1. So let's just double check that this still works. I get a mean that's about 0 and a standard deviation that's 1. If I create a new sample and try again, I get a slightly different mean and a slightly different standard deviation. So, all right, I can compute the mean and standard deviation of whatever random vector I want to put in there, some other numbers, anything like this. I can spit out this in a tibble that has a mean column and a standard deviation column, and everything's sort of still nicely organized. I can change my input. I can do all kinds of stuff. Sweet. I feel like we're really making some progress here. All right. So what I'm going to do next is actually something that's very similar. What I'm going to do is multiple inputs. All right. And what I'm going to try to do here, again, I'm going to start small. What I've been doing with this mean and standard deviation, I've sort of said, I can make x vector an rnorm size 100, and I can compute the mean and the standard deviation of that. And I could maybe change the mean to 3 and the standard deviation to 4 and compute a new x vector and get a standard deviation here. Now, if I wanted to rerun this a couple of different times with different sample sizes and different means and different standard deviations, well, I can do that, but it might be nice to have a function that says, what sample size do you want? What mean do you want? What standard deviation do you want? And let's sort of spit that thing out. And that's the function that I'm going to try to write now, is one that says, give me a sample size, give me a mean, and give me a standard deviation, and I'm gonna sort of spit things out. So let me start out by doing that. I've been, I guess, up to this point, just creating a vector here and working on it this way. And that's actually not the way that I really like to do things. Of course, if you've been paying attention, you might have noticed that just like having a vector here kind of bothers me. So what I'm going to do instead is create a simulated data set, and that simulated data set is going to be pretty easy. It's going to be a tibble that has an X column, and that X column is going to be R norm, sample size 100, mean equals 3, 4, and standard deviation equals 3. Let me just sort of be clear here. N is 100, mean is 4, standard deviation is 3. And great, I've got mean, I've got a simulated data. Here it is. Feeling pretty good about that. And if I have this data set and I wanted to compute the mean and standard deviation, I can try to use something like this. But I'm just going to sort of fall back on things that I know and love. I'm going to take sim data, and I'm not going to do that. I'm going to take this and summarize my simulated data set to say that the mean is mean of X, and the standard deviation is the standard deviation of X. Okay. Now again, the goal here is to create a data frame, and then given that data frame to compute the mean and standard deviation. So let me just double check all that works. Yeah, the mean's about 4, the standard deviation is about 3. It looks like this is doing fine. All right, now again, in this bit of code, it's starting to get a little bit more complex. I'm using inside of this function, I'm creating a tibble, and then I'm using that to summarize the mean and the standard deviation that spit out the result. And the inputs that I am interested in here, I've now got 3 inputs: a sample size, a mean, and a standard deviation. So I'd like to do this with a function. So fantastic. I've got now a simple working example, and I need to think about how I'm going to translate this into a function. So let's start building this up. So my function I'm going to call sim, mean, and standard deviation. It's going to be a function, and I'm going to sort of leave this blank for now. And I want to do something like the following. Okay. Let me make sure everything gets indented. Okay. This looks like it's kind of right, but my function right now doesn't have any inputs. And so what I'm going to say is I need an input sample size, and I need an input mean, and I need an input standard deviation. And I'm not going to use, so n I think is kind of standard, but here I'm gonna be a little bit sort of more, I don't know, statistical in my notation, and I'm gonna say there is a true mean out there in the world, and that true mean I'm gonna call a parameter mu, and there's a true standard deviation, and instead of calling that SD, I'm gonna call that true standard deviation sigma. This is again just sort of, for me, making sure that I understand exactly what these are, and these are parameters that I'm using to generate data. Now, I need my function to use those inputs, so here I've got to sort of replace whatever sim data is. Instead of just assuming this is going to be 100 and 4 and 3, I'm going to say I want this n to be my sample size. And I know this is looking a little bit weird. I've got an input n that I'm using here, and then that same argument is going into R norm as the sample size. I get that that's a little bit strange, but that's sort of what the process is. I pass in n, it shows up here. R norm is looking for something called n, and that's what it's going to use. I guess if I wanted to make this a little bit more clear, I could just call this sample size. Maybe that'll be easier for now. So I've got sample size here, goes into R norm there. Okay, and I've got a mu, and I've got a sigma. Okay, so let's run all of this. And now let's double check what happens. If I do sim, mean, and standard deviation, and I want the sample size to be 100, and mu, the true mean, to be 6, and sigma, the true standard deviation, to be 3. Let's run this. Hopefully this will give me a tibble with a number that's about 3 and a number that's about 6, and that's what I get. Okay, so again, just trying to be very clear about what's happening here. Sim mean and standard deviation has an n equal to 100. That's my first sample size. The first number is sample size. Second number is mu. Third number is sigma. And so this sample size drops into R norm here. mu drops into the mean here, and sigma drops into the standard deviation here. So given a sample size of 100 and a mean of 6 and a sigma of 3, this is sort of the structure that I'm interested in. My function then creates a data frame based on those inputs, takes that data frame and summarizes it to compute a mean and standard deviation. And so what we're sort of getting here is if I run this line of code once, it says generate that first sample, try it, give me what's going on. If I run it again, I can sort of start to get a sense, sort of the point of this is if I run this a couple of times, I get some idea about what well, let me sort of take a step back. If I run this code multiple times, each time it's going to create a different normal distribution, different numbers, and I'm going to get a mean and a standard deviation. If I do that again, I'm going to get something that's a little bit different. And if I do this over and over and over again, then I'm going to each time get a different mean and a different standard deviation, and over time I can sort of learn a little bit about that process. I can learn about how much I might expect the mean to shift away from the true value if I give it a new input collection, if I give it some new sample from a normal distribution. In general, the kind of thing that I'm interested in here, like at a very big picture, is if I was able to do this thing again and again and again and again, I would start to be able to get some idea about that sampling variability. I would know something about what the mean and the standard deviation looks like, the sample mean and the sample standard deviation in comparison to the true value. Right? So this is, we're not there yet. I'm sort of using this function in particular to lay the groundwork for something that we're going to see in a later video, which is simulations. And simulations are, I'm like, you can tell I'm already talking about it. I am so excited about simulations. I can't wait to get there. For now, they'll just sort of look. If I run this line once, I get 6.34. If I run it again, I get 6.35. And then I get 5.93. And I get slightly different standard deviations each time. I got a 5.93 twice. That's neat. And then a 6.13. I'm getting like slightly different numbers each time, and I'm learning something about randomness in the process. And I really like learning about randomness. All right, back to writing functions though. I'm sorry, we're not at simulations yet. We're gonna get there. It's gonna be great. So I guess now that I've got a few different inputs here, I guess I want to be clear about some of the things that we have been using up to this point, and that's sort of how we're structuring the arguments that go into these functions. So here, I'm not saying anything about, is 100 the sample size, or is 100 mu, or is 100 something else? What R is using here is an assumption. It is saying, if you don't tell me exactly what number this is, I am going to assume that the first number is the first argument, and the second number is the second argument, and the third argument is the third argument, right? It's using what's called positional matching. It's saying, I'm going to trust that you're putting these in order, right? Now I could use named matching. I could say, I want the sample size to be equal to 100, and it's going to know that for sure. And then if you've got named things, it'll use positional matching after that. You don't have to name mu is 6 and sigma is 3. Generally speaking, I would encourage you to use named matching as much as possible in the functions, in general, in functions that you use, things like this. I think named matching often works. Positional matching is helpful too. We use it all the time in tidyverse things. You take a data frame and you pass it in, and R assumes that that first argument is the thing that you've just passed in. It's using positional matching in that sense. But like outside of cases like that, functions that you're writing yourself, things like this, I encourage you to use named matching. And so just to be clear that you can use named matching in a variety of ways, I'm going to start out, I'm going to shift this. I'm going to say sample size is 100, mu is 6, sigma is 3 in a different order, and I get numbers that are about the same, right? So you can shift things around a little bit. Now, the next thing that you can do, and that is sometimes helpful, is provide default values for some of these things, meaning if a user doesn't tell you anything, what should you be doing instead? So I might set mu is equal to 3 and sigma is equal to 3 by default. Now, this is going to be a little bit strange. So if I have set these things by default, that doesn't mean that mu is always equal to 3 and sigma is always equal to 3. In a case like this, if somebody says, no, I really want mu to be 6, this value gets overwritten. It's going to take mu, it's going to say it's 6, it's going to plug in 6 here, it's going to plug in, I guess that's 3 in both cases. Let's change that to 4, right? So I've got mu is 6 and then sigma 3 if I run this line of code, regardless of what that default value is, right? So let's just sort of double check that these lines work the way that I still expect them to. Yeah, I get a mean that's closer to 6 than it is to 3, right? It's using this 6 value rather than the default 3. The reason that this is helpful, oops, let me copy, is now if I don't give it a mu or a sigma, I know what I want the default to be. It's going to have some value to fall back on. It's going to know what I want to use by default. So let's run this. And by default, you're going to get something that's kind of close to 3, the default mean, and 4, the default standard deviation. If I run this a few times, you can sort of get a sense for that. Okay, so now we've got, in the context of this function, we've got a little bit of complexity in the body of our function. We've got output that contains 2 numbers, multiple outputs. They're structured in a way that's nice and clear. We've got multiple inputs. We've got positional matching. We've got a variety of other things. We're actually doing pretty well in terms of writing functions, right? And so what we're going to do now is, instead of like trying to do more and more stuff with this, we are going to revisit things like this with simulations. Like I said, I like simulations. We're going to talk more about that. But instead right now, to focus on writing functions, I want to revisit a couple of past examples. So let me actually make sure I got everything. What have I done? I added multiple inputs and outputs. Great. So I've actually cheated a little bit and copy and pasted some code from a previous example, and I'll talk through that now. So let's review Napoleon Dynamite. So this is an example that comes up in various places on the course website and in some of the live session videos that go along with this course, some of the worked examples in class. But I'm going to sort of work through this now to make sure that everything kind of makes sense. So the goal here in this code chunk is to do the following. If I go over to good old Amazon and I wanted to get customer reviews of the movie Napoleon Dynamite, which people often either love or hate, although surprisingly, I guess more people now seem to love it than hate it. It's neat when you get like a bunch of 5 stars and a bunch of 1 stars. Those are always kind of fun settings. Anyways, so we get people here. I love this movie. Don't you wish you could go back? Stupid but very funny. The best, hilarious, and so on. And here, boo. All right. Told us to building a cake, talking about really think it's only good movie to 7th graders. So we do get at least some negative opinions here. Anyways, the goal of this example is not to just read Amazon reviews, but to actually gather this as data. So there's a collection of videos on additional things of data wrangling, and we talked about reading data from the web, in particular using the Arvist package. I have loaded the Arvist package up above, and here I've just sort of copy and pasted some code that we had done previously. So I've got the URL for that product review page. I'm going to read in the HTML, and I borrowed this code from a previous example. I didn't want to try to just rewrite everything from scratch, but the idea is once I have read in this HTML, again, I need to extract the elements of the data that I'm most interested in. The way that I'm going to do that is by identifying the CSS tags that go along with, for example, the review titles. So just to sort of be real clear about how I came up with that CSS tag, on this page, I use selector gadget, I click on the thing that I'm interested in, I click on something I'm not interested in, and what's left here is all the review titles, and then I can copy and paste this CSS tag from selector gadget into HTML nodes, and that's how I ended up with this. So my review titles are going to take the HTML, pull out the everything that's got this tag, and then convert it to text. And so here, I love this movie, looks right, and then boo, movie is still silly, funny, entertaining, limited quality, so on. Okay. All right, so next thing that I'm going to do, I've got review stars here. I've actually done a little bit of processing afterwards. If I just like get the CSS tag and take out the text, then I get 5.0 out of 5 stars. And I've used just a little bit of regular expressions here to say, get the first digit number between 0 and 9 at the beginning of whatever that string input is. And then I convert that from a character 5554115, I convert that to numeric and I get my review stars, okay? And then you can get the review text. And again, I'm sort of I'm doing some additional string manipulation here because if you just run this, you get these /ins at the beginning and /ins at the end. So I'm getting rid of those and then I'm trimming off these 2 white spaces at the beginning. Just a little bit of additional stuff to make sure this all works. All right, so if I run this entire code chunk and then I put the reviews into a tibble that's got title, stars, and text, I've got my reviews, I've got my title, I've got my stars, I've got my text, and I'm feeling pretty great. Until, here's what happens is, what about the next page of reviews? And by the next page of reviews, here's what I mean. I could take all of this, and I could copy this whole thing, I could show up here, and I could go from page number 1 to page number 2, and now let me run this. And I've got my reviews, although here I guess I'm not being super clear. This is really like reviews page 2. So now let me run this again. And now if I want reviews page 1, I gotta come back up here. Let's make sure this is clear. Reviews page 1, and is this the right page 1? Hopefully, yeah. But I'm repeating all of this code. And this is again sort of, I'm like being a little bit over the top. But the goal here is like, if I really wanted to say, give me the page 1 reviews and give me the page 2 reviews, I really don't want to copy and paste all of this and repeat it twice just so that I can change this character from a 1 to a 2. And if that was all that was different, if I sent this code to you and I said, one of these is page 1 and one of these is page 2, you would look through here and you'd be like, oh, this is gonna be tough. And let me just double check what's going on Amazon here. Let me get out a selective gadget. How many pages of reviews do we have here? I guess it's a little bit hard to tell, but probably more than 2 pages. There are 8,000 ratings and reviews, 1,800 reviews. We got a lot of pages, 10 at a time here. So I really don't want to just have this repeated 100 times to try to get 100 pages of reviews. That's a whole hot mess. So I got to do something a little bit different here. I'm going to take all of this and turn it into a function. Let's turn that code into a function. Now, the only input that I actually have in all of these reviews is the page that I'm getting the reviews from. The only thing that changes, once I get past this line of code, everything else in this stays about the same. So I'm sort of thinking about like, what is the structure that I want to have the inputs to have? What is the code body going to look like? What is the output going to look like? The input structure that I want to have, I'm going to tidy this up because it bothers me. The input structure that I want to have in this case, there is just the URL. It's just read this page of reviews, call it done. And I'm going to keep the URL here rather than the page number in case I decide I want to get Amazon reviews using the same function. Maybe I want to get Amazon reviews of like a toothbrush and see what's going on over there, right? So I'm going to take the input. The input's just going to be the URL for whatever page reviews I'm interested in, and then everything beyond that stays the same. So let me create a function, and the function that I'm going to call this is read page reviews is a function of a URL, and I'm going to get rid of that. And I need to close the brackets down here. And then just to make sure, I'm going to like indent this so that it's clear that everything is sort of inside. And I think I deleted a tibble parentheses. That's not what I wanted to do. Okay, and this is, I'm not going to call this page 2 anymore. This is just my reviews. So really, I've taken the code that was already working and I've done something slightly different, right? I've just said, instead of now copy and pasting that code a whole bunch of times, I want to give in a URL, read in that HTML, get the review titles, get the review stars, get the review text, and combine them into a data frame. And now I need my return object, and that's just going to be the reviews. Okay. Okay. So it's starting to get a little bit strange, maybe. I guess I'm gonna do a few things to make sure that I am clear how this bit of code differs from this bit of code, right? So again, I've said this is just my input URL. It can be anything. So this doesn't have to be Napoleon Dynamite. I'm just going to get HTML after reading the HTML. And then from that HTML, I want the review titles. I want the review stars. I want the review text. And then I want to combine everything after that. Okay. Sweet. So I'm going to get rid of this URL. And I'm just going to make sure that this whole thing is a function. Okay. And now let me try my function. So that's my URL. I'm going to say, okay, let's call this Dynamite URL. Now I'm going to try my function. What did I call it? Read page reviews on the Dynamite URL. Sorry, URL. Okay. And hopefully this will work. It's even got a thumbs up emoji. That's how great it worked. Let me, is that page 2? Has a thumbs up emoji for the title? It does. Exactly as described and came on time. Great job, Amazon. You're doing a good job. All right. So I can change this. Let's just be clear. I can change this to the first page and get my Dynamite URL, and it spits this sort of a thing out. And what's great is I'm sort of two things. I'm not having to copy this all of this code every single time I want to get the reviews. I really only need it once inside of a function, and I can pass in whatever I need to. The other thing that is helpful here is, although I've done some amount of formatting here, suppose I wanted to add some other element to the review, or I wanted to say, no, I don't really just want the digit, I want to get the entire like 5.0 stars out of whatever. Well, I can make a change inside of my function, and that's my new function, and it's going to work any URL that I plug in, right? So here I got the full 5.0 stars, and I can change this to the second one and get the second page of reviews, and the same thing works, all right? So this, boy, I am just super excited about this. I'm going to do one last thing on good old Napoleon Dynamite here, and the thing that I'm going to do with Napoleon Dynamite here is let's read a few pages of reviews. And again, this is mostly setting the stage for something that we're going to worry a little bit more about, and I think the next video will sort of revisit this. So what I want to do, let's suppose I got the Dynamite URL base, and that URL base is going to be all of this up to the number of the page that we're interested in. So I've got a URL base, and now I'm going to create Dynamite URLs, a collection of these, by combining the URL base with the numbers 1 to 5. Okay, and this again, I'm sort of getting into an area where I don't love this, because Dynamite URLs is a vector, but okay. The first element of this vector is the first page URL, the second one is the second page URL, and the third page URL, and the fourth page URL, right? And so again, I don't love that this is a vector. I really kind of don't. But if I wanted to get Dynamite URLs 1, I get the first page, and 2 is the second page, and 3 is the third page, okay? And so what I could do in addition to this is read page reviews on the first page. And I could read page reviews, let's do this, 1, 2, 3, 4, 5. Now, if I run each of these, I'm going to get a data frame, and I can put all of this together if I bind rows on this whole thing. I gotta make sure to put commas after each of these. Whew, this is already sort of getting tough. All right, now I'm gonna run this line of code so you can like see what's going on. I'll call this all reviews. It's not all reviews, but it's a lot of reviews. Okay. All right, and let's run it. And so for each of these, it's going to go page 1, go to the internet, get my HTML, 2, 3, 4, 5, and process each of those. And then it takes all of those, each line produces a data frame. And when I bind all the rows, I end up with a data frame here. 5 pages, 50 reviews. I got the title, I got the stars, I got the text. Okay, everything is going pretty great here. Now, I did say there are a couple of things that I don't love. The thing that I do love here is that I am using one function and I am applying it first to this URL and then to this URL and then to this URL. I don't love that I'm having to go through this like object 1, object 2, object 3, object 4. That's not great to me. What if I wanted another 5 pages of reviews? Do I copy and paste this and go like 6, 7, 8, 9, 10? We're making progress. The next thing that we're going to talk about in a later video is how can I just, again, we're talking about iteration. How can I do the same thing over and over and over again in the most convenient way possible? And so I've already like copy and pasted this code 3 or 4 times. I don't love it, but it's kind of working for me. So this is a nice intermediate place to say, yeah, we've got a function. That function is great. That function works if I apply this to different URLs. I could edit this function if I wanted to. I could go back to just getting the digit, getting the numbers if I wanted to, whatever. I've got a function and the function is great. But I also see that if I wanted to do this process again, if I wanted to get 50 pages of reviews, I don't want to have this line of code copy and pasted 50 times. That's going to be just a whole mess. So we're gonna worry about that next. And this is the same kind of idea, like we've got a function that simulates a mean and a standard deviation, and we might want to do that a bunch of times to see what the central limit theorem looks like. We're going to worry about that next. Right now, we're just trying to write some functions. All right, so let me, I'm going to knit this, and like I'm going to be careful. I'm not going to knit this too many more times because I'm sure Amazon already has like flagged my computer as like, why does this person keep looking at Napoleon Dynamite reviews, right? Eventually Amazon's going to cut me off, I feel sure. But that's okay for now. I do Napoleon review function. Okay. The last thing that I'm going to talk about, now I guess a similar, well, all right, I guess I'm going to talk about this, and it's already, at least in the back of my mind, started to come up. And it started to come up because I've got a couple of different variables floating around in my environment. I've got here data frames, all reviews, Dynamite review, reviews page 1, reviews page 2. I created these. I didn't like creating them, but I did, and they're there. I've got simulated data from before, and then I've got a URL and a Dynamite URL and a URL base and a Dynamite URLs, and I've got some other stuff, right? I'm starting to get enough things with the same names floating around in my environment that it could get confusing for me just writing this when I look at this function and I say, when I pass in this URL, when I say function of URL and then I read URL, is it talking about something that I'm putting into this function? Is it just using this URL that exists in my environment? This is where, as you are writing code, it can get confusing about like what's inside of my function and what's in my workspace and what isn't. So I'm going to be sort of careful here. I'm going to restart R, and restarting R is going to get rid of everything in my environment. And I'm just going to make sure I'm going to run these packages again here at the outset. And I'm going to scroll down to here where I create the function. I've got function of a URL, and that URL is going to be read. I'm going to get the HTML, titles, reviews, text, put that all into a data frame and spit it out. So now I've got a function. And I'm going to skip this Dynamite URL stuff. Again, I don't want to confuse myself too much. And I'm just going to double check. If I get the URL base and all of the URLs, right? I've said URLs now enough times that like that phrase is meaningless to me. URLs. All right. So if I take the page reviews on URLs 1, the first of these, the way the function works is it says that is the URL. It's killing me. That is the URL here. It's going to get passed in as the argument to right here. That's going to get read as HTML. And then the HTML that results from the argument passed into the function is going to be used to create the review titles and the review stars and the review text. Okay. So right now I don't have URL floating around in my global environment. I have to pass it into the function. And if I just run this line of code, then it works, right? Because again, this is the argument. The argument goes into the function and everything sort of works okay. But I guess sort of the reason that I'm pausing to review this is that when you are writing functions, sometimes it can get really confusing to think like, well, what is the thing in my environment and what is the thing that isn't in my environment that's getting passed in as an object, right? But right now my code works. Everything's fine. So I'm like, I guess I'm sort of saying this mostly to remind you to be careful about scoping, to think that scoping can be a difficult kind of thing. And I guess, let me just sort of do a mean scoping example real quick, just to sort of drive this point home. So the mean scoping example that I'm going to use, I'm going to create a quick function that is a function of a variable x, and my variable is going to compute z, and z is going to be x plus y, and I'm going to return z. And then below this, I'm going to create x is 1 and y is 2, and I'm going to run f on x equals y. And I want you to take just a minute, like click pause on the YouTube video and think for a minute about what this is going to return. Is it going to return 2, maybe 3, maybe 4, probably not 5? I don't know how I'm going to get a 1 and a 2 and end up with a 5, but maybe. All right, so is it going to, which of those is it going to be? And I do, like I say, I encourage you to pause for just a second and think this through. Okay, I trust that you paused real quick and you thought it through. So drum roll, please. Let's take a look at what happens. I get 4. And the reason I get 4 is partly because of the way that R does scoping. So here I've got x equals 1 and y equals 2. X is in my global environment, and y is in my global environment. F is a function of x, but it uses both x and y, and the argument name is x. So when I say that x is equal to y, this is saying, okay, take 2 and plug that in for x inside of my function. So 2 is sort of showing up here inside of my function, and this x is now 2 inside of my function, inside of the environment that the function is working in. So it's got 2 here, and then it says, well, I need y, and y isn't an argument. Y hasn't been passed into my function. So cool, I'm going to go over to the global environment. I'm going to find y floating around, and it gets y right over here, and it gets a 2 here also. And then it puts those two things together, x plus y, and creates z, and that's what it spits out. If I changed my function to be, like I kind of hate this, x plus, let's do x1 plus x2, and my argument is x1, and I've got x1 equals 2. This is getting a little bit strange. So again, x1 is going to show up here. I'm going to get 2 for x1. That's going to be okay in my function, and then it's going to say, you didn't pass in x2 as an argument. Let me go to the environment and find that. There is no x2 floating around anymore. So this fingers crossed, is going to break. Right. x2 doesn't work. It doesn't exist. So gosh, there's a lot here that is, I think, both confusing and also potentially problematic, right? So if you write a really complicated function where you've got something like y, and y exists in your global environment but not as an argument, you can end up, next time you clear your workspace and try to use this function, you can end up with something that breaks. And often, one of the ways that functions break a lot when you run them again is you get something like this: error in function, this thing isn't found. And that's usually a scoping issue, or you relied on something in your global environment and that sort of break. So like I say, this is a mean sort of scoping example. The last thing that I'm going to do is, again, mostly laying groundwork for something that we're going to do after this. What we're going to take a look at next is, I guess I'll commit mean scoping example. All right, the next thing that I'm going to take a look at is functions as arguments. So you've got a function and you can pass in a vector. You can take a function and you can pass in a function and have that function be a function of your function, and I feel great about that. And this is going to be sort of a strange example. I'm going to create a mySummary function, and that mySummary function is going to have one argument here, I guess maybe 2 arguments here. I'm going to pass in x, and I'm going to pass in a summary function. This is going to be sort of a strange thing, but let's suppose inside of this, I just take whatever that summary function is, and I do summary function on whatever the x input is. Okay, so again, this is probably a little bit strange, at least for now. Oh, oops, equals function here. All right, so why am I doing this? So let's see, did I create an x vector is our norm, size 100, let's say 3 and 7. So if I wanted to create a summary, I could, for example, compute the mean of my x vector, and that's that, and let's say the median of my x vector. Okay. What I can do instead, and you might be wondering why you would ever do this, but first let's just establish that you can. If I did my summary of the x vector, and then I passed in some function that is going to be used to summarize this. If I passed in, say, the mean, right? Now I've got x vector, and I can compute the mean, and that's the same as applying mean to the x vector. And I can change this to median, and I can change this to standard deviation, and I can change this to interquartile range, and I can change this to some other things. I wonder if I can change this to some other things. Let's just kind of leave it at that, right? Now, again, you might sort of think to yourself, why would I ever do this? And I guess the first thing that I'm going to point out is that we in some ways already have done this. In examples where we have done things like reordered factors according to the mean, or reordered factors according to the median. That's sort of already been a thing that we have done in at least a couple of places. The other reason that I'm pointing this out, again, is just sort of foreshadowing that before long, we're going to want to be able to say, this is the function that I want to apply to this thing. We're going to have a function that depends on being able to put a function as an argument. And that's really all that I want to say about that for right now. So I'm going to knit, and it's going to take a minute, and let's commit functions and functions. Okay, so we're gonna go ahead and stop there for today. We're writing a bunch of functions, we're doing a bunch of stuff. I guess want to reiterate first that if you're like hanging in there through this, I'm really happy about that. I think a lot of the videos, at least when viewed in a sequence in this course, there's a lot of stuff that focuses on working with data frames. And right now, we're sort of right at the beginning of this whole new area where we're going to be eventually doing simulations and iterating across a whole bunch of URLs to get all the Napoleon Dynamite reviews. But we're really shifting gears from something that had been like ggplot and tidyverse and other stuff. We're now writing functions, and that's a strange thing to be doing. So it is a little bit of a shift, and it may not be entirely clear all of the reasons that we're going to be using these, at least not yet. But this is really, I'm really happy with that you've stuck with it up to this point, and that you're making progress beyond that. So good work, keep it up, everything's awesome, and thanks very much.